Well, hello, probable people. What are the chances that you just happen to be at a loss with a spinner probability question, and just by chance, you clicked on something, which resulted in our meeting now? Shall we? Probability questions involving a spinning wheel can seem daunting. So let's break down a small problem to see if we can apply these steps to more complex problems. Joining us is my pal, the Perplexing Probability Pie. My well-rounded friend has compartmentalized himself into 3 equal sections, and he is displaying a number on each section. In the red section is the number 3, in the yellow is 5, and in the blue is 8. Suppose we were to spin Mr. Pie twice. When he stops after the first spin, we will record the number that the pointer is on. We will then spin him a second time and record the number of the second stop. After obtaining the 2 random numbers, we will multiply those 2 numbers. But before we do that, our curious minds are eager to answer the following questions. 1. What is the probability that we will get an even product? 2. What is the probability that the product will be greater than 10, but less than or equal to 32? 3. What is the probability that the product will be divisible by 3? 4. What is the probability that the product will be divisible by 5? Because we have 3 numbers, with each number having the possibility of being multiplied by itself, and each of the other 2 numbers, we take the total number of numbers, which is 3, and multiply that by the number of numbers by which it can be multiplied, which is also 3. 3 times 3 is 9, so we will have 9 possible outcomes. So let's plug our numbers into something that will help us organize our calculations. 2 methods come to mind: a probability tree and a sample space table. Either method is effective, but our preference is the table. Because we are using the same set of numbers from 2 spins, we will have the same data for our x and y axes. On our y-axis, we will chart the numbers for Mr. Pie, which are 3, 5, and 8. We will do the same for the x-axis. Next, we multiply the corresponding numbers from each axis, just as we would on a multiplication table. This way, we don't miss any calculations. After plugging in all our numbers, we will list our calculations, as shown here. This gives us an organized view of our calculations. We can see that we have 9 outcomes. Yay, almost finished. Now, let's evaluate each product and determine whether it is true for each question. Here we go. Question 1. What is the probability that we will get an even product? We can see from our table that 5 products are even. Question 2. What is the probability that the product will be greater than 10, but less than or equal to 32? We have 5 products: 15, 24, another 15, 25, and another 24, which are all greater than 10 and less than 32. As for questions 3 and 4, which ask for products that are divisible by 3 and 5, respectively, we can see that we also have 5 products that are true for these as well. So the answer to all 4 questions is the same. 5, what are the chances? Okay, not to spin out this spin the pie party, but here's a word of caution. Do not omit turnaround facts when determining probability. For example, in our problem, we had both 3 times 5 and 5 times 3. We also had 8 times 3, and then 3 times 8. A common mistake is to ignore the reversed factors, which is similar to pulling out a blue sock from the sock drawer and dismissing it because it was the second blue one during a trial. Every outcome counts. So we must count every outcome. I wonder if that's like saying what you mean and meaning what you say, unless what you mean to say is too mean to say. So you don't say what you mean because it would be too mean to say. You know what I mean?